Hi there, this is Andrew Kroll. Today I'm going to go through how to make a really crappy game for the Nintendo Entertainment System. To do this, we'll be writing in an assembly language, which I basically wrote myself. It's called Wiz, and it targets 6502 assembly, which is the assembly language that you would use to write NES ROM games, typically. The 6502 being the CPU that is in the NES. Well, not strictly the 6502, but rather an offshoot of that hardware called the 2A03. It's just basically the name of the CPU. Anyway, so you have to write a program that will actually run on the NES hardware, and to do that, you need to target the machine code that hardware interprets. So basically, I wrote an assembly language that will compile to 6502 machine code, which you can then run as an NES ROM, and from there you can run it in you can run it on an emulator, or provided you actually have the hardware, you can go ahead and just put that onto your flash cart or whatever and put your cart in your NES and play it that way. Now, the things that we will be making aren't going to be very elaborate at all. They're just going to be like to get you off the ground running. In fact, I don't know that they're going to be any more elaborate than other tutorials out there for NES development. But this particular set of tutorials, or at least one tutorial, I don't know how many I'm actually going to do, is going to be geared at writing a ROM using my assembly language called Wiz, because there are no tutorials right now for that language, and in fact I'm the only one using the language at this time. But I figure it's kind of a useful tool, and if I document it, maybe other people may be interested in doing homebrew development for themselves. So, with that in mind, let's get started. So, first off, I just have an empty demo folder, or nearly empty anyway. I have one file in here, and it's called wiz.exe. If you double click on it, you just get this little dialog window that just goes away. It just pretty much says, oh, no input files detected, and yeah, I'm gonna quit now. So Wiz is the assembler that we're using, and right now it's not going to do much because you need a whole lot of other shit going on here. But there we are. Also, I think someone just messaged me on Facebook, but I'll ignore it for now. Alright, so here we go. Let's start. I'm going to create a really dumb demo project. So, I have some scaffolding that I've already written ahead of time, because there's actually a lot of shit you have to do to get a starting program on the NES. I don't expect anyone new to the hardware to understand it, and it's better to just take it as it is and use it that way and figure it out later, rather than just... That didn't really come out very articulate. What I'm just trying to say is, like, you're better off just accepting things the way they are on this, rather than trying to understand at this point, just because it's not really worth learning all this shit when it's basically something you never have to change, or very rarely have to change. And really, what we're interested in is writing a demo project. So we're going to create two files. One is called main.wiz, and the other one is called hardware.wiz. The file extension doesn't really matter. I just went with .wiz because that's seemed like a good convention for what I was doing at the time. Anyway, so let's open these files up. So for starters, we have main.wiz. It's currently empty. I'm going to fill it up with a bunch of rubbish. So if we go over here, hit paste, hit save. So we have a bunch of shit here. We have some defines at the top. We just let k equal to 1024 because there are some things in here that are just kind of multiples of kilobytes. So rather than having to write that out all the time, it's easier to just write a single letter and multiply by that. So for instance here we're defining a RAM bank of 2K. That's how much RAM the NES actually has, 2 kilobytes of RAM, which isn't very much to work with. That's only 2048 bytes of memory. So you can kind of imagine that you're pretty limited in what sorts of games you can write on the NES. You can get extra RAM if you have certain cartridges and stuff like that, but we're just going to go with the very basics for now. Then we define two other things. We define a program bank. The program bank contains 16 kilobytes of ROM memory, and the character bank is another bank which is used for images, character images, and that contains 8 kilobytes of memory. Now those two things combined just kind of create your main program. That's the stuff that actually gets written to ROM along with the header. And the header is just a bunch of rubbish here. You basically don't have to tinker with this too much unless you're changing your cartridge format. For now we're just going to use the really basic cartridge format, which is no special hardware on the cart, no extra memory, no hardware interrupts or any special shit, just plain old NES ROM, which has been used for some really small short games. I can't think of a good example, but anyway, so there you go. And yeah, this shit here is just kind of like it is the standard header used by a lot of emulators. It's called the INES format. It's just, there isn't really a standard so much as just something that emulator writers all agreed on, and it just defines the specification of your cartridge. So you have all this shit here. Next up, I have some variables I define in RAM. For now, I just created 16 dummy variables, T0 to T15. They're just temporary variables, which might be useful for some like scratch calculations and stuff. Not really sure yet. Next up, we have our program starting at address C000 blah. We include hardware.wiz, which is going to define a bunch of hardware related things, like basically a bunch of different hardware that's on the NES. Rather than having to remember the magic number to write to specific addresses in memory, you can just kind of use these named constants and make your life a little bit easier and make things a little bit more organized. So next up, we have our main function here. Main in this case is just kind of the first thing that is hit when you start up your ROM. Basically, it determines how your game is set up, and then after that, it just kind of goes into a busy loop where it just kind of like keeps repeating itself. And yeah, so it's basically the main game logic is what's going to happen here. So we have so all I have right now is a bunch of boilerplate. So there's some shit here where you have to like turn off decimal mode, which doesn't really mean much on the NES, but people do it anyways. We enable the interrupt flag, which in turn means that no interrupts can be triggered. We clear the stack register to the top of the stack, and we do this by assigning through the X variable, or X register, because only the X register can be transferred to the S register, and the S register can't load immediate values directly, but it needs to be initialized to 255, or else you can't use the stack, which is kind of shitty. Or you can, but it has... Anyway, you just do this and deal with it. Anyway, so there's that. And then there's some other shit here. You have to like turn off the video, and you have to disable all the sprites and shit. And then you wait twice for 2 vertical blanks on the screen. Basically, the screen has to be drawn twice before the video card PPU, picture processing unit, is ready to actually be used for video memory. Until then, it's not really safe to write there because it's just kind of like warming up and it's kind of garbage at the moment. You might think it might even be unsafe to write to the PPU before then. I'm not really sure. I don't really know that stuff. Anyway, and then next up we have a loop where we just kind of clear out all the memory at the first page of the RAM. So basically we clear out from 0x00 to 0xFF. Those are all going to get cleared out, and then once we've done that, we're actually ready to go. We can do whatever the hell we want after this point. So for right now, we just kind of do an empty loop, and that's not very exciting. We also have this draw function, draw task actually. Tasks are basically my fancy word for interrupt handlers. Yeah, so you have 2 interrupt handlers. Interrupt handlers being things that are triggered by special hardware. They'll break the flow in your program. So instead of doing this loop here in main, where it just kind of like loops infinitely, every now and again, when the screen is ready to clear during the vertical blank period, when it's actually like safe to like write to video hardware and stuff, it'll trigger an interrupt, which allows you to stop what you were doing before and start writing to video memory without having to explicitly check for the PPU status all the time in a giant loop, which would be really messy. It's doable, but it's really messy and requires like a lot of extra busy work. And then finally there's a scan task, which we're not really going to use at all. Scan is just what I called it because I use it for scanline interrupts normally, but we're not going to actually use this at all in this project. So right now it's just kind of like pushing on a bunch of registers, popping a bunch of registers. Same with the draw, it's just pushing on a bunch of stuff and then popping it off again. You have to push and pop because if you don't, then the register states that were there before you triggered the interrupt will be all corrupted, and you don't really want to do that to your main loop. If you're in the middle of something and then the interrupt fires, you want to make sure that all of the state you triggered gets knocked off again when things are done. So that's just doing that. So then we have this little magic down here at the bottom at 0xFFFA. We're setting up the 3 interrupt handlers, well, 3 entry points rather. We have our draw task, we have our main function, and we have our scanline function. They always appear in this order. Just how it works. This is the way the NES hardware expects them to be, and it has to appear at this exact address in ROM. It's actually the last 6 bytes of the NES address space. It's always hard-coded to be this. So that's just kind of shit like that. And then finally there's this in character bank address 0. We don't actually do anything here, but inside of the character bank we can embed a bunch of assets like artwork and stuff, and that'll actually get drawn to the screen. That's more or less, or yeah, sorry, it'll be used by the video hardware to like draw tiles and stuff. So yeah, those are our things so far. I just need to do one more thing and then we're ready to get started here. This is not very fun. We're like 15 minutes in and I haven't even written any code, but I've done a lot of explaining. So maybe what I'll do is just kind of run through the hardware descriptions and then next video actually go through how to write an NES ROM, or a really simple demo program anyway. Yeah, sorry about all the setup. It's just kind of like there is a lot of shit you have to cover before you can get anywhere with this. Alright, so opening up Hardware Wiz. Right now it's empty, but whoa, hold on. I'm going to copy and paste and you'll see a bunch of shit appear. Alright, so here we are. Now I have the Hardware Wiz file. If we look here, we have a bunch of different let thing equals some magic hex value, let data equals blah blah blah. Yeah, these are just defining the different hardware registers on the NES. Hardware registers being the things that actually control different parts of the NES hardware that aren't on the CPU. So all the external hardware outside of the CPU has to be addressable through memory mapped hardware registers. They have specific addresses in memory. They always map directly to the NES hardware on the other end. And whatever you write to them just goes to that line in the hardware. Something like that. I don't really know all the low-level details. I'm sorry, I'm kind of ignorant. Anyway, so there's like the PPU has a control, mask, status, scroll, address, and data register, and these all do different things. Control and mask just kind of like define the basic master behavior on how the screen is drawn. Like, do you want to draw sprites? Do you want to draw a background? Do you want the leftmost column of the screen to be drawn at all, or do you want it to be clipped off? Do you want the sprites to be 8 by 8, or do you want them to be 8 by 16? Do you want to actually have an interrupt when you get a vertical blank? And different stuff like that here. You get to determine in what order the VRAM gets written to. Do you write horizontally across the screen, or do you write vertically down the screen? For certain things like modifying the tile map, you have to adjust the vertical, or like you have to adjust the step so that you can write a whole bunch of tiles to the screen without having to set up the address register all the time. There's a whole bunch of other shit here. Oh yeah, and then there's like the audio processing unit. It has a square wave, a second square wave, a triangle wave, a noise wave, a bunch of sequencer flags and shit. There's a joystick. It has an output port and 2 input ports. Then there's specialized hardware things for the MMC3, which is one particular cartridge. I've just kind of hard-coded stuff for that because it is a useful... It's one of the more interesting mappers out there in that it's used by a lot of the awesome later-gen NES games like Star Tropics and Kirby's Adventure and Mario 3 and a few other games. So it's actually pretty useful, and it's used by a lot of commercial games near the end. So I don't know. I personally really like this particular cartridge mapper, but it doesn't really matter. Yeah, this is just me rambling. I'm sure everyone else is kind of bored by this, but that is it so far. I've just kind of created a really dumb project. And now for the last step. Why don't we create a file that will just build a dummy ROM that does absolutely nothing, just builds a ROM. So let's do this. We're going to create a new file here. We're going to go new text document. I'm going to call this build.bat. It has to be a bat file because bat files are the only way to run commands easily when you want to double click. Otherwise you could launch CMD and type in a bunch of commands every time, but I don't really want to do that, so I'm just going to create a bat file here. Next up, we're going to do one of these echo off things. We're going to put a pause at the end so you can actually see the output that we get back. And we're going to just do a quick whiz, main.whiz. The 6502, the output format we want is, what do we want to call this? How about demo.nes? That's what we're going to get out of this. And when we're done with that, let's just see if this works. If we hit double click, it wrote out demo.nes. If we click on it, it'll create this really dumb demo ROM here. Oh yeah, and if you're wondering, I made it so that NES files will automatically open with my favorite emulator of all time, FCEUX. It's one of several emulators out there. It's not the most accurate, but it has a lot of very useful tools that make it really easy to just debug while you're writing your code and stuff. I don't know, I kind of like it anyway, but I'm biased. Like, I have a bunch of different emulators here, so if you see I have FCEU, I have FCEUX, Nestopia, Nintendulator, NesterJ. Anyway, there are like a bunch of different emulators. There are like 5 billion NES emulators because everyone and their grandma writes an NES emulator for some reason, because it's like the biggest emulator market, I'd say, like in terms of people actually writing emulators for it and stuff, because it has the most varied hardware, I guess, in a lot of ways, so it's kind of neat. Yeah, so there we go. We have a dumb NES ROM that does absolutely nothing. Next time we may actually fill our ROM with code that will actually do useful things. But that's it for now. Sorry for wasting 22 approximately 22 minutes of your life. Yeah, see you next time. Okay, bye.